All right. Good morning, good evening. Thank you for joining early. All right. I think we are already 9 a.m. here in Singapore. Let's get started. Thank you for joining. Welcome, welcome. You can let me know from where are you joining, which country. You can type in the chat box. Yeah. Hey, I'm Fauzi. Welcome, welcome. All right, let's get started. Right. Okay, welcome to the activated heat exchangers in Aspen Plus webinar. Right. Okay, I hope you can hear me. Give me a feedback if you can hear me well. Sounds good. Okay, thank you, Farouk. All right, thank you, Muchibo. All right, so I'm going to skip this. Thank you for being here. This is just a little bit of um, informations. This is the link of the upcoming sharing sessions. So I will be doing sharing sessions about preparations on to preparations for Aspen HISIS user certifications exams, right? I will also invite a few of my friends to also share their experience. They have got their HISIS user certifications, right? So the link is here. I will also share this slide deck later on. I will post the link also in the chat later on, right? Okay. Also, so we do have a chat window. We also have a tab for questions, right? So you can post your questions there uh, in the question tab, right? I will go through that later on, right? So I'll go through the presentation first, then I will go back to see if there's any questions, right? Okay. Okay. Right. Just a disclaimer. So myself, I'm speaking from my personal capacity, right? So what I'm sharing here does not represent the view of my current or my past employers, right? So this is my personal view, right, based on my experience, right? And they may or may not be supported by the current employer or past employers, right? So just a disclaimer, right? So I'm doing this out of a personal capacity, right? So this is the agenda. So I've done this for HISIS, the integrations between heat exchangers and Aspen HISIS. But today we're going to focus on Aspen Plus, right? Uh, so how we actually model rigorous heat exchangers in Aspen Plus, right? So we will start with the heat exchanger model in Aspen Plus. We will size the heat exchangers we have in Aspen Plus. We'll go to EDR to review the design case, then switch to a rating case, right? Then next, after that, we will import back the uh, heat exchangers to Aspen Plus for model for simulating the performance rigorously, right? Then we will then we also going to talk about sometimes we want to convert the rigorous simulations back to a simple model and then using a UA constant, right? So we will talk about how to convert that back to a simple model, right? So if times allow, I will show you how to generate the heat exchanger data sheets, right? So I will share this also to the participants here, to those who has registered, right? This I might not go through this slide deck by slide, but this slide will be shared. So this slide has uh, the step by step. I try to be really rigorous and going through step by step. So I've captured the screen captures here in this slide deck. hopefully this will be useful also for you, right? Okay, so let's get started. Wow, from Nepal, Rajiv. Thank you. Right. So this is myself. Just introductions. Get to know myself a little bit. Hopefully, I can also get to know you later on. Right. So I study chemical engineering. I am originally from Indonesia. Right. Then I moved to Singapore and pretty much settled here. Right. So now I did my master, but it's in business from National University of Singapore. Most of my career mainly in engineering. So I start off from EPC in the upstream world, McDermott, right? So we McDermott built platform at the time, right? We design and construct and install platform. Then I move on to pure engineering wholly, so mainly doing feed on and a little bit on the downstream regasifications, a little bit of refinery and chemicals. Then I move a little bit even more upfront in terms of the engineering, so doing feasibility due diligence for regasifications, refinery, power plant, and many others. A little bit, I spent a short time, maybe 1 year plus in operating company, FOPAC. We have, FOPAC has 5 terminals here in Singapore. So I was the lead process engineers and project manager for the FOPAC Singapore. Right. So since 2019, I joined the solutions technical solution consulting, which is more of a technical role, technical and sales role in Aspen Tech, right? So helping customer here in, especially in Southeast Asia, on their planning their use of the software, road mapping, and many things, right? Okay, so that's brief introductions about myself. Thank you. All right. So let me go to the software directly, right? So I have created this simple Aspen Plus model, right? Let me go through. So in terms of the properties here, right, you can see under the component list, I only have two components, right? So this is basically I'm example I'm modeling a gas cooler, and the gas itself I'm just modeling as a methane, and I have water as the cooling medium, right? So only two component, straightforward. The method I'm just using the common Peng Robinson, right? So that's in terms of the properties, and in terms of the simulations, it's also straightforward. So I have this stream of hot gas, right? Is the temperatures is 100 Celsius, and I want to cool it down to 50 Celsius, right? So we have the flow rate defined here, flow rate pressures, temperatures, flow rate, and the compositions as pure methane, right? And we have this cooling water also. So my target of cooling water is from 30 to about 50, right? Maybe it should be 40, but yeah. Okay, so that's the cooling water flow rate. So let's say you have built this model. So essentially, when we build this heat exchanger model, right, you add this in here as a heat exchanger, you connect the stream, add the stream details, right? So mainly this is a heat and material balance type of uh, simulations, right? So you can see here under the heat exchangers is a shortcut module, right? I can choose here, for example, the hot fluid is in a tube. I can specify what is my exchanger specification. There are different specifications. Typically, I choose what is my target temperature, the outlet temperature for my hot stream, right? So in this case is the methane, the gas, right? So I want it to be cool to 50 degrees C, right? So for this also typically you have your pressure drop, right? So even I forgot to add this. So you can define the cold side and the hot side pressure drop, right? I think that's pretty much it to define heat exchangers in Aspen Plus, right? So heat and material balance, as long as we know the um, the duty for one stream, right? So it will calculate the outlet temperature, right? Okay, so that's kind of a brief explanations about the model I'm going to use, a simple heat exchangers. So next is the next task I'm going to do is I'm going to size these heat exchangers, right? So it is very common, right? Be it when you are in engineering company, right? Or you are as a owner operator working for front end engineering. So typically we want to know, we can give this into a data sheet and give it to a vendor to size. But sometimes it's good to know two things, right? We can do a preliminary sizing of the heat exchangers, right? To either to know exactly how big is this heat exchanger. That helps us with the planning of the project. Like for example, how much space we need to allocate for these heat exchangers, right? And also it's useful for doing the preliminary sizing. So when you have your fender design, the heat exchangers design from your supplier, you can always cross check and see where is the difference, right? So okay, first task is to size these heat exchangers, right? So you can double click here the heat exchanger under specifications, right? So you can see here, I can choose the model fidelity, right? So there are different types of here, which is basically will call uh, different Aspen exchanger design and rating, right? So in this case, I will use shell and tube, right? So I will use shell and tube. So it will bring up this menu, right? So basically I'm converting to a rigorous exchangers, right? So the type is shell and tube. I will size currently because the intention is I want to get the size of this exchanger. So I will size these heat exchangers, right? Of course, the later on we will talk about when you already have the size, when you already have the file from the EDR, you can import that or you can specify the exchanger geometry, right? So currently we don't. We want to get the size. We want to size the exchangers, right? And typically I choose size interactively, which will bring up the EDR windows. I think I'm more comfortable with that, right? So with that, we can choose this. This is the default, and I'm fine with that. We will size this shell into heat exchangers, right? And I can click this convert. Oh, sorry. I need to run this, make sure the right. So because I changed just now, I changed the input. Right, so result is available. Now I can do that, right? So let me save this also so that I don't overwrite my file. Right, so let's go shell and tube. So shell and tube size heat changes size interactively. Click convert, right? Right, so it will bring up this kind of a browsers of the heat exchangers, the EDR shell and tube, and you can see here the mode is now we are in mode size design or sizing, right? And this is the mode what we want. You can see here if in shell and tube, right, there are parameters which is not going to be optimized. This is are the basic parameters of the shell and tube configuration, such as thema type, right? So we have to choose what is the thema type. This is based on your service, maybe the temperatures, right? Whether you need floating head, etc., right? Then the locations of the hot fluid, the tube diameters, so the tube pattern. So these are the things are not going to be optimized. We have to specify this. Of course, if we want to do a study, we can change it and run it as a different case, right? So what EDR does when it's doing a sizing, right? Basically, it will calculate the required uh, surface area, right? What is the required surface area to deliver the duty, right? And basically, it will determine, okay, what tube length I should use, right? And based on that, how many tubes I need to use, right? How many baffles, etc., right? How many passes, right? So these are the things which is being sized or calculated or optimized by EDR, right, in this design. Okay. Uh, so in terms of the optimizations, we'll talk about when we go into the EDR later. By default is cost of optimization, right? Minimize cost, right? And you can see here the process data is pretty much transferred here. Okay, you can see the. Of course, we can increase if we want to increase the margin, for example, on flow rate, on heat exchanger, we can do that, right? I think one thing which here I think we can put this hot side target temperature is 50, right? Okay, and also I think the what we need to pay attention also in additions to the process data, right, is automatically transfer. You need to look at whether you need to put margin. You want to put margin. The other thing is the uh, allowable pressure drop, right? So this is basically I go by default about 10 psi. Then maybe the fouling resistance, right? How much fouling resistance you want to uh, consider, right? So I'm putting some numbers here, right? So pretty much we are done. We don't need to actually do the entering of this data. It pulls the data directly from the process simulations, right? Now I can do the sizing, right? So what EDR will do, it will iterate based on uh, different configurations, right? It will vary the length of the tube, the number of pass to actually come up with the optimum minimum cost for the heat exchanger, right? So we will click this size, right? So you can see it's evaluating various case, right? It will tell you which one is okay, right? Okay, so now they have come up with the design, right? Uh, you can see if there's any error, right? And we can go back to the geometry. It actually shows you the rough sketch of the heat exchangers, the temperature profiles, the tube layout, right? So what I'm going to do now, I'm going to save this file. I can save this design as a EDR, right? So let me create this. So this is, let's say, the heat exchanger design number 1, right? That's the EDR file. And if let me go back to that folder and open this file, right? Okay, you can see the same input, same output, right? But of course, when we open it in the EDR, we have more handles or more things we can do, right? So typically, that's what I do. I do a sizing. I do the sizing in Aspen Plus or HYSYS. I will save the EDR file and do more in EDR. For example, right, in EDR, we can go into this. We can specify constraint, be it like, for example, a layout constraint geometry, like I don't want to have the length more than certain length, right? I want to have this in one heat exchangers, or how many in series or in parallel. This is something we can define, right? This is process limit, right? You can specify, and of course the optimization. So there are two. By default is minimum cost, right? But you can also choose minimum area, right? So we have more handle, and you can see here under result you get more result. One of the important result for me is the optimization part, right? It tells you what all the heat exchangers it considers, right? The different heat exchangers, right? So you can see here, this is the selected configurations, right? So it will tell you also for different tube length as configurations, right? Whether that design is okay or is almost meeting the criteria, right? The criteria mainly are two things: the pressure drop criteria you have put, right? Whether it's exceeding the pressure drop, we have allowable pressure drop we have specified, or not, and also the area ratio, right? So whether the this design actually will have area more than the required area. That's the area ratio. So it should be more than one, right? Or if you need buffer, then it should be whatever one plus the buffer, right? So this is one of, I think it's one of the important. Of course, all the details of the heat exchangers you can see here. Okay. Uh, okay. Right. Some drawings. Let me go back here first, right? So remember we have saved the design number one, right? So let's say I accept this design. I wanted this to be incorporated into my Aspen Plus. So I can click this accept design, right? So it will transfer the geometry, and now it switched. It's modeling the heat exchangers under simulation mode, right? And basically it's using the uh, rigorous heat exchangers model, right? Rigorous shell and tube heat exchangers, right? So the pressure drop, the heat duty will be calculated based on the geometry. Okay. Okay, of course, there's some warning. I think the warning is on possible vibrations. So I'm not going to address that at this moment. Right, so you can click this dashboard to look at the summary of the heat exchangers. And you know this heat exchangers is in rigorous mode because the mode status is referred to simple. That means it's now is in rigorous, right? Okay, you can go also here to show the model status or legend here. You can tick that and you can go back to the main flow sheet and it will show you whether this is the legend, right? So warning, risk, right? Okay, now let me go back to this heat exchanger, this EDR. So this is, let's say this one is this is under design mode, right? So you can see under design mode, the heat exchangers, right? Let's go back to the geometry. The input is only this much, right? Now, what I'm going to do, I'm going to choose the different heat exchangers, right? So let's say I want to have the number 4 design, right? So instead of 16.7 length, I want to 15.7 length. Let's say I select this, right? Okay. So now I want to switch to rating mode, right? So I'm going to use that current design. So if I switch to rating mode, right? If I go to input, geometry summary, right? So you can see here, the geometry summary just now was only this part, right? Is specified. Now, because now we already have, we copy all the results of the geometry into an input, because in rating we fully specified the geometry. So now you can see we specify the shell diameter, we specify number of tubes, right? So now we can check this in feet, right? So this is the design number 4, right? You can see the length is 15, not 16, right? So now I can run this case, right? So in this is typically, I think is done. You run a design case, then you switch to rating. So rating case, it can be for fine tuning the design, or also can be used for checking existing heat exchanger, whether it's sufficient or not, right? The main output of the rating is, you can check here under performance. It should is under the main output is the area ratio. Typically, these are the things we look at, whether the area ratio is bigger than 1. Right. So I have now design case 2, which is the geometry number 4, right? Let me save this, right? So I want to save this as rating case number 2, right? So a different geometry, right? So I can go back to this. Remember, just now we convert the heat exchanger by sizing it and importing the result of the sizing. Now I can actually specify the heat exchanger, right? So let's check first. Make sure that when we go to the EDR browser here, right? So you can see here tube length, right? This one is the first design, 16.7 feet, right? So let's say that okay, we have fine-tuned the design, and we find it that the design number 2 is more suitable, right? We can import, right? We can replace the EDR file with that, right? So we've done the size heat exchanger. Now we specify the geometry, right? So we can click this specify geometry, right? We can import the EDR file, right? We can browse. So the EDR file is this, rating number 2, right? So I can click convert. Okay. So let me run. Okay, it's done. Let's go to the EDR browser. Right. So you can see now the tube length is 15, right? So I imported the second geometry into this Aspen Plus file, right? Okay. So I've talked about sizing. Let me go back to this agenda, right? So I've talked about the simple heat exchanger model, right? So I've talked about, let me go back to this, right? So I've talked about the heat exchanger model. I've talked about the sizing. I've talked about the EDR, reviewing the EDR, right? Performing the design case, right? Perform more detail in the rating mode, right? Choosing that, converting the heat exchanger from design to rating mode. Then I've talked about the importing the heat exchanger back, the geometry back to Aspen Plus, right? Okay. Now I'm going to talk about how we convert from rigorous model. But sometimes we have a big flow sheet, and we want to capture the characteristics of the heat exchanger, but we don't want to run it. I mean, if you have a rigorous model, sometimes it does takes time to calculate, right? Because it will perform rigorous calculation. So sometimes we want to convert it. We want to capture the essence of the characters of the heat exchanger, and then typically that is represented in UA. UA constant, right? So the A represents the surface area, the U represents the heat transfer uh, coefficients of that heat exchanger, right? Of course, the heat transfer coefficients is based on a certain operating conditions, right? Certain, let's say, certain flow rate, because if the flow rate change, technically the velocity will change. It might affect the heat transfer coefficient, right? So if, let's say, we say the in my simulations, the maybe the flow rate will, or the operating condition will not change too much, I can still rely on the UA as a constant, right? So I will talk about this, convert back the rigorous heat exchanger model to a simple mode, right? Let's go back here. So we know, how do we know this is rigorous? If we go into the model setup, right? So we know this is shell and tube is rigorous, right? If you go to the EDR browser, you can open it. That means it's rigorous. The other thing also, you can double click, you can click this dashboard. You can see B1 referred to simple. Means what? Means that the B1 currently is actually rigorous mode, right? So I will show you two ways of converting this back to simple. The first one, of course, through this dashboard, refer to simple, you can click this, right? So it will ask you what type of model you want, shortcut. And typically, I will actually use this shortcut, but I will copy the calculated UA and the pressure drop, right? So I can click this, that. So basically, it will specify this instead of right. So now it's basically running on simulation, but it's using this constant UA, right? The pressure drop should be also based on okay, this is using the outlet pressure, so but that's calculated based on the pressure drop, right? Okay, so that is the first method. It's actually just a different button, right? So let me switch this back, right, to rigorous, and I'll show you the second button, right? Yeah, if you have questions, you can feel free to post it on the Q&A tab. All right, done. So the second button is actually just here. Copy calculated UA to input. So this is, you can see this is a calculated UA, right? We start modeling as a rigorous heat exchanger. If I click this, it's basically converting, and we just copy, right? So that's the two button location where we can switch from rigorous back to simple heat exchanger, right? Okay, I'm going to again convert this to save this first. Okay, I'm going to convert it back to, so the last task is actually to produce data sheet, right? Let me convert it back again. It's performing the calculations. say, all right, it's not available. Okay. All right. So if you go to home tab, right? Okay. Now to produce datasheet. So the requirement is you need to have Aspen Basic Engineering installed in the same machine, right? In your laptop or machine, right? So if you have that, you should have this datasheet icon, right? I'm going to so here essentially the Aspen Basic Engineering is the tools we can use to produce datasheet, PFD, hidden material balance, equipment list, right? So we can actually export the data from ISIS here or Aspen Plus to the basic engineering. Right? So I'm going to show you how to do that, uh, uh, and it can be used as like you use it this as your standalone system in your laptop, right? That means that the basic engineering data is stored in your laptop, but you can, if you have multiple people working on a project, you can also set up this. You're connecting to Aspen Basic Engineering server, right? You can click this select workspace or reconnect, right? So it will ask you. So in this case, right? So I'm using this laptop as a server, so I'm using personal workspace. But if you use the Aspen Basic Engineering as a project, a common collaboration project, you can point to the server of the Aspen Basic Engineering, right? So you can point to the location, right? So in this case, I'm using this as a personal workspace. Right? So what happening now is basically Aspen Basic Engineering will read what are the flowsheet object in this file, right? So it will identify the streams, the equipment, right? So we only have one equipment. Sorry, this is okay. So we can choose to connect to existing street workspace, existing project, or we want to create a new one. So let's say I'll put it this demo one. Okay. So it's creating the project database, right? Okay. Okay, it takes a little bit time. So it's reading the information from the Aspen Plus. What are the objects in the Aspen Plus? Right? So we have one heat exchangers, 4 streams, right? So you can see here, then it will transfer the data. We will transfer the data to the database and it will create the workspace object. So currently it's create, you can see, you can choose create or not create, not mapping, right? Here you can see the heat exchanger, 2-stream heat exchanger, right? You can choose as a plate exchanger, double pipe, etc. In this case, we are choosing as a shell and tube exchanger type, right? So I will transfer the data from Aspen Plus to Aspen Basic Engineering, right? So it creates this object now. Okay. Now I can go to, so you can see now I'm connected to a local server. I'm my workspace demo one, right? I can go to Explorer now. So here is where I can see the different objects in the Aspen Basic Engineering. Okay, it's populating. Right, now I can choose, for example, the shell and tube. I can tick this. And here is the different button, like creating PDF file. This button is the one to add datasheet. Right, so you can click this. You can choose AT, shell and tube, heat exchangers, right? And click OK. So we have a default heat exchanger format, datasheet format. You can see the process data, it get transferred to this datasheet, right? So we can save this as an Excel. We can export it to an Excel file, right? If you want, right? I will show you also a different way of generating this datasheet, right? Through the Aspen Basic Engineering, right? So you can open Aspen Basic Engineering, a call Explorer, Explorer ABE version 14. Right, so I'm going to connect to the workspace, right? Remember the workspace was demo one, right? So this is the workspace we created. We can open it. Okay, now we can see, for example, the equipment, different major equipments. There's this heat exchanger. So we can also see this data sheet. It's already created, so we can open it later on. But I want to import data from the EDR, right? So there is a tools, thermal design. You go to tools, thermal design, right? So file, import from a file. So which I'm going to import from the rating file, right? So the intention is I want to import the geometry, right? So it's importing the EDR file. It's opening and reading. Okay, it's done. We need to see the log, right? So I can close this. Right, so now I can open the datasheet. I double click this datasheet. It will open an Excel, but this is a datasheet, right? A link datasheet, I mean. It's not a dummy Excel, but you can see here, all the data is get transferred already. So it's very easy to produce this datasheet. All the process data, all the configurations of the heat exchangers, right? It is copied here in this data sheet, right? So for example, if I add something here, let's say the client is Fauzi. If I add that, right? If I go back to this Aspen Plus, you can see this is updated. So if I update it here also, it will get updated there, right? So Fauzi 2, right? So it will be updated here, right? So this is a link datasheet, right? Although the format is Excel, right? So these are the two ways of generating. You can generate within Aspen Plus. You can import the file. Currently, importing the file is actually gives you more information. It imports the geometry. So when you create the datasheet, it fills up all the geometry also, right? Okay, so I think we've covered uh, all the stuff we want. Let me go to the let me go to what you sorry, if there is any questions, right? Okay, let me go to the Q&A. Right, so there is a question from Viraj. The key takeaway. Yeah, let me read slowly. Yeah. Yeah, thank you, Viraj. I think that's a very good summary of takeaway, right? Thank you so much. Right, I think we are quite there. Let me go through. So this slide deck. Give me 1 second. So this is all the steps later on, right? You can go through this on your own, but pretty much what I've demonstrated just now, right? So maybe, yeah, yeah. If you find it useful, you can use it, apply it in your day-to job, right? So I don't talk about in details about the sizing it or the designing of the heat exchanger. I'm mainly today talk about the workflow from data transfer of Aspen Plus to the sizing to changing to rating mode to importing back to Aspen Plus, right? I don't really go into details of selecting thema types, etc., right? I think that's a more detail and needs more expertise of the heat exchanges. We can review, for example, books, etc., right? Yeah, hopefully, but I hope it was useful. Yeah, so if you found it useful, you use it, yeah, let us know, right? You can tag me on LinkedIn, post your success, right? You can connect me on LinkedIn. So that's my LinkedIn. You can scan this to connect, right? You can share your success story, right? I also uh, uh, have this feedback form. So let me know your feedback on this session, right? Let me know this your feedback. I've typed it in the chat window. So help me. Okay, there is a one question. Hi Fauzi, is it possible to carry out similar analysis for MSHE? What is MSHE? Sorry, come again. Let me search MSHE. Multi-stream. Okay, multi-stream. Okay, multi-stream is we can do. Okay, there are few multi-stream model we can do, right? The first one is plate fin exchanger. The second one is what do you call that? Coil wound, and plate fin exchangers, right? So this for those two model, we can model it rigorously in Aspen Plus or Aspen HYSYS, but the model in EDR is mainly a rating model, right? So you need to specify. It will not give you the design, but you can change the geometry to come up with the design, but it will not come up automatically like in the EDR in terms of number of tubes, etc. So you need to specify your geometry, but you can model that to simulate the performance of the heat exchangers in Aspen Plus, right? Yeah. So I hope that answers. So yes, so I will do that. I will do that sometime in the futures. Um, the multi-stream heat exchangers. Also, let me know through the feedback form, right? You can fill up you can fill up the topics you would like to see. So help me with the feedback form, fill up. Let me know which topic you would like to see in the next demo session, right? So also we have coming up few sharing sessions around Aspen HiSys user certifications, tips sharing, right? So I will post it also. Okay, Aircool from Farouk. Yes, we can arrange that. So I will post this session 1 sharing HiSys user access. Oops, how do I find the? Okay, anyway, I have posted this in my LinkedIn, the registrations, right? But I will, let me try to edit. Oh, this become text. There's no. Okay, let me do one thing while we are still here. Okay, let me post this. Sorry. Let me post the link. But anyway, I think our session is pretty much there. Don't forget to give feedback, suggest the topics. Let me post the different link for registrations of the next session. Right? So the next session mainly on preparations of the HiSys certification. Okay, let me post it there. You can register. Let me post. Sorry. Aspen CapEx and OpEx estimator is also interesting. Yes, I will do that. CO2 capture design equipment. Okay, yeah. Let me know. Yeah. So these are the registration for. Okay. So there are a few sessions, right, to cater for different time zone. Please, you can choose which sessions you like. And the last session is basically in Bahasa Indonesia. Okay. All right. I think that's about it. Oh, the agenda for the session in the evening is the same. So it's just to take care the different time zones. So if you already attended these sessions, you don't need to attend the evening sessions, right? Is exactly the same, right? Thank you, Avijit, for asking that, right? I hope that is useful session for you, and thank you very much for attending, right? I hope to see you in the next session, right? Yeah, Muchibo, the session 1, 2, and 3 for the HiSys exam user certifications is also the same. Typically, I will have multiple sessions to cater for different time zone, but the content is the session same, right? So Harsh, yes, you have one questions, yes? Anything? If not, then yes, thank you everybody for coming. I'm glad to have this session. Hopefully, it's useful, and see you again. Thank you, Asha from India, Hazik from Pakistan, right? Kadim from Senegal. Wow, thank you, thank you. Kamat from Malaysia, Rajiv from Nepal, Agung from Indonesia. Hi, Glenn. Thank you from good evening. Have a good rest. Thank you for joining on your Saturday evening. Yes, today evening will be the same, right? All right. So we have reached to the end of the sessions. Thank you so much, and I'll see you again in the next, right? So you can look at my LinkedIn. Typically, I post in the future sessions in my LinkedIn post. Yes. Okay. Thank you all. Have a good day.